Now the next level of structure is known as the tertiary structure, or tertiary level of structures for proteins. Alright, so now let's say a protein has several alpha helices. Okay, so I'm just drawing several parts of the protein. So many alpha helices like this, and say many beta sheets like this. So this is one beta sheet, this is another beta sheet, this is another beta sheet, right? So now if there's interaction between, and I'm going to draw all this on this part of the slide, so you have to watch what you're taking notes about. So let's say there is a interaction between this part of the protein and this part of the protein. What kind of interactions could there be? And just to make it easier, I'm going to erase this part. Okay, what kind of interactions could there be? For example, there could be hydrophobic interactions. Hydrophobic interactions. Now what does this mean? Interactions between amino acids that have non-polar R groups. Okay, so let's say there are several sections of the protein that have non-polar R groups. What happens? All these non-polar groups are pushed away from the solvent or pushed away from the polar solvent. So they all interact together and they form the hydrophobic center. Hydrophobic center of the protein. Okay, and they all are pushed away from the polar environment. Now, in the same way, all polar, okay, all polar amino acids can group together and they can form the hydrophilic center. Okay, these polar R groups are pulled onto the outer surface of the protein. They are pulled onto the outer surface of the protein where they can interact with the aqueous environment. There can be hydrogen bonds. So there could be a hydrogen bond from here to here. There could be a hydrogen bond from here to here. And if you notice, this is the internal part of the protein, and so this is the hydrophobic part. Okay, and the rest of it is the outer surface, and that would be the hydrophilic part. Also, there are some amino acids that have sulfurs, right? So there might be a sulfur here, there might be a sulfur here, okay? And sulfur can link to form disulfide bonds. So the other one we talked about was hydrogen bonds. And then there could be disulfide bonds. Disulfide bonds. All these will contribute to the tertiary structure of the protein.